With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Question is, a particle of mass 200 gram is moving in a circular path of radius 10 centimeter such that its tangential acceleration varies with time at as 60 meter per second square. The average power delivered to the particle by the force acting on it in the first 10 seconds is 100 kilowatt. The particle starts from rest. Find K. First 10 seconds is 100 kW. The particle starts from rest. Find K. So here it is said that the average power acting in the first 10 seconds is 100 kW. Hence average power can be defined as, let's say, integration of, we can say here as p dt divided by, we have here as integration of dt. This is the average of any quantity. Here average of power will be integration of p dt divided by integration of dt, with limits here as in the first 10 seconds means 0 to, we have here as 10 seconds. Now this power here can be written as, this is the instantaneous power, which here can be written as our F dot, we can say here as V. So in a circular motion, we can say here in this circular motion, here there is a particle moving in, let's say, this circular motion having, let's say, some tangential acceleration which increases with time. So we can say here along this tangential acceleration there is a tangential velocity, and along this tangential velocity there is acting, let's say here, our tangential force. So we can say here this is the tangential velocity, this is the tangential acceleration, and here this is our tangential force. And the centripetal force, we can say here, let's say, has contribution of 0 power, as we know power is equal to F dot V. So here we can say, since centripetal force is perpendicular to velocity, so it's here contribution of power will be 0, hence whole power will be due to the tangential force. So we have here as Ft into V into, we can say here as cos of 0 degree. This is the instantaneous power here. Now we can say here instantaneous, let's say, power can be written as this tangential force as mass into tangential acceleration into, we have here as V, we can say here. Now mass is given to be 200 gram, that is we have here as 0.2 kg, and this tangential acceleration here is given in the question as our 60. So this tangential acceleration is given as 60 into, we have here as V. So this comes as our 1.2 into, we can say here as V into T. So on substituting the values, we have here as 0 to T, we can say here this value of P comes out to be our 1.2 into V into T into, we have here as dt divided by, in the denominator integration of dt comes as T, with limits here as from 0 to, we can say here this is also our 10 seconds. So this here is 0 to 10 second, as well as this is also our 0 to 10 second. Now expressing this velocity in terms of time, we have here as tangential acceleration given in the question as, let's say, 60, whereby we can say here this tangential acceleration can be written as our dv upon dt as 60. Hence we have here as dv is equal to, we can say here as 60 into dt. Now integrating this, we can say here 6 is a constant, so it comes outside. Now we can say here this is, let's say, it says it starts from rest, as it says the particle starts from rest, hence at t equal to 0 velocity is 0, and we say here at some time t its velocity becomes v, hence integration of dv becomes our v with limits here as 0 to v, and this here gives us as integration of t as t square upon 2. Now with limits we can say here as 0 to t. So this gives us v minus 0 as our 3t square. So we have instantaneous, let's say, velocity as our 3t square. So we can say here this comes out to be 1.2 is, let's say, coming out of the integration 0 to 10. Now v can be written here as our 3t square into we have here as t into dt divided by, in the denominator we have here as 10 minus 0. So this gives us as, we can simplify this, so 1.2 by 10 becomes our 0.12 into, we can say here this gives us as 3 into integration of here t square into t gives us as t cube into dt. So this comes out as 0.36 into, we can say here this integration gives us t raised to power 4 divided by 4 with limits as 0 to 10. So this cancels out, hence this becomes 0.09 into, we have here as 10 power 4 minus, we can say here as 0 power 4. So this comes out as our, we can say here as 900, we can say here as watt. This is the power. Now comparing this to, here it says this power P comes as 100k watt. So we can say here comparing it to our 100, we can say here k watt. So we can say here value of k from here comes out to be our 9. Hence our final answer, we need to find here value of k which comes out as 9. Hence 9 is our final answer.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.